Definition of line segment. A line segment is the part of a line that lies between two given endpoints. The difference between line segments and number sets we discussed earlier in this tutorial is that line segments may lie in other directions besides the number axis because, as we have seen in the previous tutorials, the orientation of a line is not always only horizontal or vertical. We usually refer to line segments when dealing with linear graphs. Line segments are useful when we want to focus our attention on a particular section of the graph. For example, the line segment A, B, in the figure below makes us focus our attention only on the part of the graph that lies horizontally from x equals 1 to x equals 7 and vertically from y equals 3 to y equals 6. We have the following shown on screen. Line intervals are like line segments but don't include the two endpoints. If A, B in the above figure were a line interval, it would include all values between A and B, but not A and B themselves. There exist the half intervals and half segments as well, when dealing with parts of a line. Example. We have the following shown on screen. A. Find what type of relationship points A and B, B and C, C and D and E have with each other. B. Write the corresponding number relationships in symbols by considering each direction separately. C. Write the equation of the line shown in the graph. Solution. Point A is indicated in the figure by an empty dot while point B is indicated by a filled dot. Therefore, we have the half interval A, B in the first part of the line. Again, given that point C is indicated by a filled dot, then BC is a segment. In symbols, we write it as BC. On the other hand, point D is indicated by an empty dot, so CD is a half segment. In symbols, we express it as CD. Last, point E is indicated by an empty dot as well. Therefore, DE is an interval. We express it as symbols as DE. B. Point A is at -11, 10, and point B at -5, 6. Hence, using the segment and interval symbols we obtain for the given half interval in each direction, A, B, x equals -11, -5, and A, B, y equals 10, 6. We have expressed A, B, y as 10, 6 instead of 6, 10 to point out its downward direction. The same thing is true for other parts of the line as well. Point C is at -2, 4. Therefore, we write for the segment B, C in each direction, B, C, x equals -5, -2, and B, C, y equals 6, 4. Point D is at 4, 0. Therefore, we write for the half segment CD in each direction, CDX equals -2, 4, and CDY equals 4, 0. Last, point E is at 10, -4. Therefore, we write for the interval D, E in each direction, D, E, x equals 4, 10, and D, E, y equals 0, -4. Remark. The line segments A, B, and B, A express the same thing, both of them express the part of a line enclosed within the endpoints A and B. C. We can take the coordinates of the endpoints of one of the above line segments to determine the gradient of the line, no matter whether a point is included in the set or not. Let's take for example the coordinates of point C and D. Thus, given that x, C equals -2, y, C equals 4, x, D equals 4 and y, D equals 0, we obtain for the gradient m of the given line, we have the following shown on screen. The equation of the line shown in the figure therefore, we have the following shown on screen. We can find the value of the constant n by substituting the coordinates of any known point of the line in the equation. For example, let's choose point D, 4, 0. Thus, for x equals 4 and y equals 0 we have the following shown on screen. Hence, the equation of the line shown in the figure, we have the following shown on screen. That is all for lesson 14.5.2. To continue this tutorial, please watch 14.5.3, Finding the midpoint of a line segment. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.com.